Alright, time to talk volume. This is going to be awesome. Alright, so we got basically 5 different solids that we're going to be talking about. One of them is prisms. All of these up here are prisms, okay? Now, you got triangular prisms, rectangular prisms. Cube would be like a square prism. Now, what we have here is 2 of the same bases, right? In this case, you can leave our base being a rectangle. In this case, our bases are triangles, all right? So rectangular prism has a pair of rectangle bases. Triangular prism has a pair of triangular bases. A cube is just all squares on each side, right? Okay, but those are all considered to be prisms. And then down here at the bottom, we've got our cylinder. You can actually kind of see that a cylinder, right, just has 2 circle bases. So it almost fits into like the prism family, and actually the volume formula will be very similar to that, okay? A sphere is kind of in its own little world, right? And then we've got a cone, which is kind of like a pyramid, but different. A cone has a circular base that goes to a point. A pyramid is like a square base or a rectangular base. Could be a triangular base, could be a hexagonal base, all sorts of different types of pyramids, but comes to a point up at the top. Okay? So different than a prism. Cool. So those are our 5. We're going to go over the formulas for each volume. So let's talk prisms. Now, they're a little bit tricky to draw, but I'll go ahead and draw it anyways. What you're going to have is, say, I draw it like this. I draw like a rectangle or a square to start. And then I'll bring these lines back. Line them up. Boom. Got myself a nice rectangular prism. So the volume of a rectangular prism is, you can think of it as your length times your width times your height. Or the way I like to think about it is the area of my base, so length times width, big B, would equal length times width. Okay? So we can think of the volume as being length times width times height, or big B times my height. I choose this one, and there is a darn good reason as to why. Let's chickadee check this out. What if I've got myself a triangular prism, and I'm going to draw it as like a right triangle. Okay. Alright, so I got that. These are kind of tricky. I like to actually draw another triangle that's the same, or at least an attempt at the same, and then I connect my points to give it that 3-dimensional look. Okay, well, how the heck am I going to find the volume of this? Well, if I figure out the area of my triangular base, right, that's this guy here because it repeats itself, these are my bases. If I find the area of the triangle, then I can just multiply it by my height, which would be this dimension right here. So this one, volume equals the area of the base, the triangle, times my height, would also work. Look at that, same formula. Although the area of my base is different, because base times height divided by 2 gives me my triangle's area, I don't have to remember a whole different formula for the volume of this. If I can find the area of the triangle, multiply by the height, we're good to go. Cool, cool. So why don't we do a little example? Let's say that this is actually a right triangle. Okay, I'll put a right angle in there. I'm going to give you some dimensions. We'll keep it somewhat easy this time around. All right. Let's say that this is 4 inches, and then let's say that this is 6 inches, and let's say that my last dimension here is 10 inches. Okay. So we got some room to work with now. Let's do it. Well, what's the area of my base going to be? Well, it's a right triangle, so base times height divided by 2. My base would be 6 and my height would be 4. So 6, oops. Sometimes this thing freezes up on me. 6 times 4 divided by 2. That's 24 divided by 2, which is 12. So big B, the area of my base, is equal to 12. So my volume is going to equal 12 times 10, which equals 120 inches cubed, because I'm talking about volume, right? That was super fun. So this takes some previous knowledge of areas, right, which is all the way back in Unit 1, and now it's applying it into volume. Gotta retain that info. The cylinder is why I like to think about the last formula as big B times height. Check this out. If I've got a cylinder, what we have are basically a couple circles, and then I just go ahead and I connect them, and that's a pretty darn decent cylinder for our purposes. And I like to draw the center of the circle, and the center of the circle, and oftentimes I'll even pop a radius over to the side, okay? So the formula for the volume of a cylinder is the area of our circle, pi r squared, times our height. Or, what is this right here? That's the area of our base, or big B. So our volume is equal to the area of our base, big B, times our height. Look at that. Same formula as a prism. If I can find the area of my base, and I just multiply it by my height. Cray cray. Same formula, but it's a different base. It's a circle base rather than a rectangular base. Okay? So let's pop some numbers on this bad boy and figure it out. Let's just say my radius, right? What if my radius was 3 inches? And let's say my height is 12 inches. Okay. That sounds like fun. Not at all to scale, but whatever. Let's find out our volume. Well, let's figure out the area of our base first. That's easy. Pi r squared, right? So pi times 3 squared is equal to 9 pi. And I'll keep this guy exact for now. So that's the area of my base. Big B equals that. So now my volume is 9 pi times 12, which is 108 pi. So this would be inches cubed, right? That would be my exact final answer. Or we could make it approximate. I'm going to jump down here because that formula is in the way. If I were to plug that on my calculator, just 108 times pi, I would get 339.3 inches cubed. Again, volume is cubed. Cool. Either one is great. A lot of times we'll find those decimals in the construction side of things. In math, we often leave stuff exact, okay? So we will work with both. You ain't going to get away from exact or from decimal approximation. We use both. Time to get into some pyramid action. Okay. So much like a prism where you can have different shapes for our bases, like could be a square, could be a rectangle, octagon, who knows, triangle, right? The same goes with the pyramid. We just have one base, and I'm going to start out with just like a square pyramid. Now when you draw this, it tends to look almost like a rhombus, right? Just to give it that 3D tilted look. And then I pick a point, generally like around the middle here, and then I just connect. It's a little bit tricky to draw on this thing to get it all lined up, but there you go. That's pretty much a square pyramid. And one thing you'll find as well is you end up having what we call the height, which goes from the top down to the center of the base. Okay, that is our actual height. And then there's also something called a slant height, but that was used in surface area. Okay, so for volume, we're just worried about that height, which is indeed perpendicular to the base. All right, there we go. So, what's our formula? Well, the volume is equal to the area of our base, right? So big B, the area of the base, in this case, which is going to be a square, times our height, that dotted green line, it's perpendicular to the base, divided by 3. Okay? Again, that big B, rather than think of it as all different types of formulas when we were dealing with a triangle or an octagon or a hexagon or pentagon or rectangle or square for your base, we just call it big B. We already know all those formulas. No need to muddy this up, right? Okay, so let's put some numbers down. How about, let's say that this is 10, and it's a square pyramid in this case, we'll say, so this is 10 as well. And then we'll say that this guy is 9 for my height. Okay, and we'll go with feet. Cool. So how do we figure this out? Well, my area of my base is 10 times 10, which is 100, so big B equals 100. That's a pretty easy one. We should be able to handle that in our head. 100 feet. Whoop. And then, and that's units squared, right? So I'm actually going to go like this, 100 feet squared. That's area we're talking about. And then let's plug it into our volume formula. Volume equals 100 times my height, which is 9 over 3. Now, I can plug this in my calculator, but I also notice I could probably do some simplifications here and make this a little bit easier on myself. What's 9 divided by 3, right? I could take a look at these two. 9 divided by 3 is 3, so simplifies to that, and I get 300 feet cubed. That would be my volume. Awesome. Now, if I'm dealing with any other kind of base, whether it's a triangle or a hexagon or whatever, it's the area of the base times my height divided by 3. We'll have some different practice problems, but it all stems from this awesome, super cool formula. Time for some cone action. Alrighty, so to draw a cone, I pop a circle, kind of like a flattened out circle, again, to give it that three-dimensional look. And then I just pop a triangle on it. Cool. Or I guess the top half of the triangle. I'll also throw in the center of that circle and a radius, because that's important. Now for the volume of a cone, it's our area of the base, big B, times my height. My height is, I'll draw it like the last one is the pyramid, will be this green guy, which is perpendicular to our base. And then we'll divide that by 3, just like the pyramid. Area of the base times the height divided by 3 gives us our cone. Well, let's see if we got some dimensions here. How about my radius? We'll make my radius 4. We'll say centimeters. And we'll say this guy here is, how about 5 centimeters? How am I going to figure out my volume? Well, the area of the base is pi times my radius of 4 squared. So that's 16 pi. We'll keep it exact for now, okay? And then let's plug it into our formula. Area of the base is 16 pi times my height of 5 all over 3. Well, 16 times 5, let's see what we got there. We're going to be at 80. So 80 pi over 3. And that would be centimeters cubed. So that would be my exact answer, right? That is my exact answer. But I'm going to make this a little smaller and work the get the decimal answer as well. So this is exact. For approximate, I can just type in my calculator. 80 times pi and divide that by 3. I get 83.775, so we'll say 83.8 centimeters cubed. And that makes sense, actually, that it's pretty close to 80 because pi is pretty close to 3. So if I'm taking pi divided by 3, it's pretty close to 1. So very little change. Alrighty, awesome, great, grand, wonderful. That's the volume of a cone. And all of this is applicable, which we'll get into in another video. And finally, we have the sphere. Alrighty, so the formula for the volume of a sphere. This one's not very intuitive, as some of the others may have been. Volume equals 4 pi r cubed over 3. The one main thing that makes sense to me is the r cubed, because it's volume, and you're thinking units cubed. That is our formula. So the only dimension we need is our radius for this bad boy. Alright, so what we have, let's say we're given us, how about 6 meters. Okay, so volume equals 4 pi 6 in for my radius cubed over 3. So what I'm going to do is I'm going to work this in my calculator real quick without the pi in there. So 4 times 6 to the third power, and then I divide that by 3. That would give me a 288, and I just toss the pi at the end. So that would be our, let's see here, meters cubed. That would be our exact answer. If I want an approximate answer, I can just multiply out the pi. I would get 904.778, so we'll just say 0.8. Look at that. Change the 7 into an 8. That was cool. And that'd be meters cubed. So that would be my approximate. Okay? Not too bad. So when we're plugging into our calculator, we're dealing with pi or we're dealing with radicals, I usually just toss those off to the side, I wait, and then I throw them in at the end there. It's kind of like the numbers are the main course and the pi is your dessert. You wait till the end, otherwise you'll spoil your appetite. Look at that. That was fun.